This is the second video on the box, doing the electrical, putting it together, and fixing the problems. Okay guys, so we printed the box for the second time, a little bit taller, bigger. The lid is going to go on the bottom, it's going to screw to the bottom. We had some holes for the LEDs. Actually, those are for the switches. I just noticed right now, I'm looking at the video, you can see on the bottom there's the holes for the LEDs. But I'm just showcasing, how that was going to work. Here's the momentary switch. Is going to be the reset switch. I show it there on the schematic, and I actually wrote there the reset switch, and the LEDs on the top where it's gonna, the indicator lights, like whoever hits the button first, the light comes on. And I was just going through the schematic, but I decided to make a separate video, well, not separate video, within this video, how I go through the schematic and how all those connections to the relays. It's a rat's nest, you can tell, but it's really hard to go like record it, do it, and at the same time. So I installed in the switches there. I think I lost the nut and I was looking all over for it. And there I had to take it off another switch and put the nut on there. I took it off because I need to solder those first, put them together. I was going to use that LiPo battery, but the connection, I had to use another connection for it, and I already had those lithium-ion batteries. I just put them in series, so I got the 7.4 volts. And here I'm testing the switches, the latching switch. So you hit one, and the other switch you hit it, and the red one come on. And I'm using that arcade button as a reset. See the yellow one come on. That was my reset, but I'm gonna end up doing using that small switch for the reset switch. Like I said, I'll go through the schematics in a close-up, in a different view, because it's really difficult. Put in the arcade buttons in there, you put in the nuts, and then you put the switches on the arcade. That's funny because I was trying to test the machine hitting those buttons on the top and wouldn't work. Like I'm hitting it, like it's not working, but I hadn't put the switches onto the buttons. So there, I put them back and it was working. I put the other switch on the other one and it was working. And there you can see I'm using the small black momentary switch for the reset. So I just threw everything in there, made space for everything. I secured the switch and it was working. So now let me go and show you how the electrical works. We're going to start with the schematic, and this is the electrical schematic I found for a self. Here, I'll write it down so you know what I'm talking about. This is called a self-latching relay. So what it does, it uses the energy you get in to self-latch a relay, and you can say it auto powers itself to stay closed, so energy keeps going on and you got a light and stays on. That's basically kind of like what you see on the video with the buttons on the box. So this is what I found. This is the best system I found. It's really simple, even though it looks complicated. Once you get the hang of it, really, you guys gonna really like it. It's kind of simple. And over here we have a normally open switch, so nothing goes through. There's no energy, there's no contact. So this one is normally. Here, let me copy that, and I'll go. This is gonna be normally open. Normally open. That means it's normally, what it says, it's normally open. If you're not pushing on it, it's normally open. So that one has its name already. It's switch 2. Okay, let me get rid of this. So you have the battery positives coming in. It goes through the switch because it's already closed, so it's normally closed. So we have the current going in, and it's going to a normally open. Basically, this is the schematic I'm gonna share with you guys. You can download it on the Patreon page. So that's why I'm doing it with you here. So we have a normally open switch. We have two switches. If you notice the same positive cable coming in first through the switch, and then it goes to a momentary switch, switch 1. Let's say this is the yellow one and this is the green one. It goes to an relay open side and goes to the other switch and the other relay open side. We'll get back to that later. But first we have the switches. We have two switches which are normally open, okay? Now, you see that KM2, KM1, KM1, KM2? This is the relay contacts where one's closed, one's not closed. Now, let me get a picture of them so I can explain, okay? So this is difficult, so I'll just explain, okay? So I'll be right back. Okay, this is the best picture I found. This is the relays I'm using. Even though this is a 12 volt, you can see right here, 12 volt. I'm using a 5 volt. So, I mean, don't mind that. It doesn't matter. Now, what matters is this right here. You notice there's 2 pins, and then there's 3 pins, 3 pins. This right here, this is the coil. So we have a coil. I'm drawing with my mouse, so please forgive me. Okay. So whenever you put 5 volts through this, you know what? I know what I'm gonna do. I'm gonna color code this. There you go. So this is the coil, which is this right here. So again, I'm gonna color code this. This is green. Okay. Now, this is the coil. This is what you put those 5 volts. This is 12 volts, but this is what's asking for 5 volts. So this is what's gonna activate the relay. Now you see these 3 pins? It's 2 different relays. So it has 2 poles. That's why it's called double pole, double throw relay. That's what you're gonna look for. It's gonna be called double throw, double pole relay. That's what it's called. Okay. So if you look for them, and make sure you get a 5 volt. Let me write on there. It's gonna be a 5 volt double pole, double throw relay. Okay. So these 2 right here, they call them the contacts. One side it's normally closed and the other side is normally open. Okay. The way these work are a little different than a regular relay. This is the wiper, and once normally closed, wiper normally open. Okay. So let's draw this one first. This one's normally closed. So the way I'm gonna draw it, and then you have a wiper. This way wiper D. This one is normally closed. And then we have another contact. And then I'm gonna go. And I'm gonna do this. So that this wiper is not. It's making contact with this one right here. Okay. So if you connect something to this pin and then to this pin, then to like make that circuit we made earlier with that LED, it's a closed circuit. So energy is going to go through. But then this one over here is the normally open. So whenever you put those 5 volts through this one, right here, you put 5 volts, this wiper is going to switch. And I guess we can show you like this. So when you hit that 5 volts, this switch is going to come over here. If this one has voltage, the 5 volts it needs, so this wiper is going to turn. So now this one is the one that's closed, and the one that was closed turns into the open. So there's no circuit here. No, I'm sorry. No circuit. It's open, and the circuit now it's closed with the other pin. Okay, so this repeats on the other side. I mean, I can even flip this like this. So, but that's if power is going through. See, those two pins now are connected. But if we cut the power, this pins, and go in here. You cut the power, this pins automatically would come back to its normally state, which means normally these two are normally closed, this one and this one are normally open. Okay, so that's what it is. You put power, it switches this one, these two are switched to normally open and these two normally closed. You turn the power off, they go back to its normal state, which these two are normally closed and these two are normally open. I mean, that's the best way I can describe how to do this. If I'm wrong, please, I would like to hear it in the descriptions. So this is the relay we're gonna end up using. So we're gonna make all these connections. So let me kind of explain here. So this is the momentary switch, and we're gonna have two relays. Remember, each relay has two sides to it. Okay. So if you notice on the schematic, we have relay 2. It's normally closed. See, this is closed, normally closed, which would be this two right here. And say, you know what we can do? Well, we have two relays, right? So here, let me get the best. Like this. I can get everything this way. Okay, so relay 2 normally closed, so that means you would use these two pins on relay 2. Okay, you would hook the normally open switch to one of these, okay, and the other one is going to go to the relay. See this, that it's this one right here, it's the green. So okay, let's do the color code. So this is the coil that activates the relay. So that means we're using dark green. So that means this is the coil, which is the dark green. So I'll just use the square so it doesn't get all ugly. So this is one coil, and this is coil for relay 2. Okay, so that means everything is green, right? So well, let's see, we're gonna erase all that information. That's relay 1, relay 2. I'll just erase that and put in the information for you guys. So we have, and we'll call it, let's see, we'll just go small and go relay 1, and we call this the coil. Okay, that's relay 1 coil. We'll duplicate this, go here, and I'll just change the name, and I'll go relay 2 to coil. Okay, so we're using this color, what do you call it? Color code. So you all have a better idea what we're talking about. You know what? I know what we can do. I'll take this. Oops. Make it a little bit smaller. Put it right here and move this whole thing over. There you go. So now we can see everything together. I'll just go like that. There you go. Maybe like this. There you go. Okay. So this is the first momentary switch, which would be the what do you call this? The arcade button. Okay, so this is the arcade button. Different styles, but if you notice, it has 3 contacts. Again, same thing as here. Normally closed and normally open. This 2 would be open, this 2 would be closed, or this could be like the wiper. So this and this is normally closed, this and this normally open. Okay, so you'll have to see, usually on those buttons, it'll say on there which one's the normally closed and the normally open. And usually it's like normally closed, normally open, and then this one would be called the common connector, and normally common, normally closed, common, normally open. So the commons like you use would be like it's used for both of them, right? So you can have power here, it goes this way. When it switches, the power goes the other way. You're gonna use those. You're gonna look for the normally open because we're gonna use it normally open. So you're gonna have an extra connection you're not gonna use. So just make sure you use, if it's this and this for the normally open, you use those so it's hooked up. So the power comes in, is gonna go into the common. Okay, I'll delete that. So it goes to the common and then to the normally open. It's gonna keep going. Then you're gonna hook it up, which is relay 2, which is this relay over here. Relay 2 normally, if you can see it, it's closed. So it'll go to the normally closed switches, connectors, the common and the normally closed on relay 2. Okay, so I'll put here the other one. Relay 2, relay 1 is the normally relay 1. This. There you go. So relay 2 normally closed. We're gonna use 2. See, that's why you need 2 sides. On relay, we'll go with relay 1. Relay 1, we're gonna use the open. So let's say we use this one and this one. Relay 1, we're also gonna need a close. So you're gonna use this one right here and this one. So I can do this. You're gonna use those. And I can delete that. So when I use this relay right here, it's gonna be used those 2. It's open. And this relay 1 open, relay 1 closed. So it's gonna use those 2 right there. Okay? I don't know if that makes sense, but I mean, that's the best way I can explain it. So we have, then from there, we're done with the relays if we hook them up like that. So you have the second switch. In my case, you saw I used red and the other one's yellow. Doesn't matter, yellow or red, blue, whatever you want. Make sure you put it on the normally open. So how this works, the power's coming in through this switch. And when, say you hit this switch right here, you're the first one to hit the switch, the power is gonna come in, right? And it's gonna go through that normally, this one is gonna go to the normally closed. Power is gonna keep going because the system is closed. So power comes in, it can't go through here, it cannot go through here, it cannot go through here. It wasn't able to go through here, but you hit the button. So now it goes through here, it goes to that contact that's closed, again, this one right here. It keeps going, it goes this way, it goes through the LED. I'm going to change the schematic on this because we have to use the LED. This is an incandescent bulb and it's not going to work. So it's going to go, the LED, it's going to come on. The LED will turn on and it's just going to go to ground. Okay, so the light comes on. But if you were to release the relay, the switch, the light goes off. But it goes to the LED, but it also goes to the relay 1 coil. Okay. So that's why this is the switch 1 where the relay 1 is at. So power comes in, goes through the switch you closed, goes through the relay 2 open connection, keeps going through, it goes through the relay 1 coil, which is this right here. Oops, wrong button. So it's this right here. So it goes through the coil, and remember when the coil is activated, this too changes, right? These were closed. Now these were open circuit. Now it's a closed circuit. This was a closed circuit. Now it's an open circuit. So these 2 connections will not go. So remember, that means when you hit this button and this coil activates, this relay opens. Okay, so if the other person hits that button, because he hit it first, this coil opened, and even though he hits this button, this relay is open, so nothing can go through. So these both now are open. This is open, and he can hit it as many times he wants. This will not work. Okay, so now remember, we have a relay 1 open, which now when you hit the button activates the coil. Now the relay 1 open circuit, now it's a closed circuit. And remember, the closed circuit, now it's an open, so this will not, no energy will go through. But now the relay open circuit closes, right? So energy comes, you hit the button, energy comes in, it activates it, it closes the open circuit. Now energy can go through here. Okay, so that means you can release the button and there's no energy going to go through here, but because the first time you hit it, it activated the coil. Now this is activated, energy keeps going through, and it keeps the coil activated. See? So you hit the button, goes through, it closes, more energy keeps going through. No more energy, but the energy keeps flowing too. You can have this button closed for a long time. This relay is going to close. It's going to close the circuit. So whenever you release this, it doesn't matter because this one's closed, energy, and it's auto. The relay 1, it's activating this wiper. They call it a wiper. So this connection is still closed, and it's activating the coil that keeps it closed. So it auto. So that's why it's called self-latching. It self-latches itself, and the energy keeps flowing to the negative. Okay. And some of the energy goes to the LED, and it goes to ground. So you hit this one, all this turns on. Now over here on the second button, because this relay on relay 1 changes state, it opens. Okay, so nothing, now it can't go through here. Nothing activates relay 2 coil because this is normally open. Relay 2 is not activated, so it's normally open. But relay 1 was activated, so instead of being closed, it's also open. So the second bulb will never come on because there's no way for the energy to come in, even if you close this. So you have to be the first one to close this circuit. Okay, I know it's really difficult. Go through the video and see it several times, make sure you understand. So basically that's what it is. So the coil self latches itself, so it closes. Now say he hits the second switch is the one that's pressed first. Okay, energy comes through, it activates the coil, it closes its own, normally open, it closes it. So energy comes in, it self latches itself, it keeps giving itself energy to come on, the light comes on too. But remember, relay 2 has a closed side also, which is this one over here. So it opens the relay, which is normally closed because you're activating this one first. So now this one doesn't work because this stays open, and now this is open. The relay 2 normally closed switch is now open. So switch 2 won't work because there's no energy. The circuits are open, and even if you hit the switch, there's a break here for energy. So switch 2 doesn't work. I'm sorry, switch 1 won't work. Switch 2 stays on the light. Okay, that's the best way I can explain it, guys. And I've looked all over the internet, and there's nobody like really explains it like it is. I know it's a really long video. I think it's like half an hour already, but that's how it works. Okay, I'll try to trim this video, but that's how it works. Now bombilla means like bulb. We're gonna change this to an LED. So first thing I'm gonna do is delete everything. So I would say I'm using a 7.4 volts, okay, on the system. That's what I use, like I say. So you kind of use you go on the internet and you use a what do you call it, a resistor calculator for LEDs. I mean, it varies, but if you want to be safe, just go ahead and use a 1K. Okay, so basically that's it. This is the schematic I'm going to put up on the Patreon page. It's a self-latching switch. I'll just put it like this. So we have momentary switch. Oh, okay. Last thing. Let me get rid of. I'll move this to the side. Last thing. Once you press that button, you know, this opens, this closes, energy comes in. It's self-latching. So the energy is going to keep flowing and flowing and flowing and flowing. So when you want to reset the whole system, this is what you press. That momentary switch that's normally closed, you press this, you break the circuit, so you have a normal, now you have an open circuit, so no energy is going to go through. So say this was the one, the latching one, energy stops flowing through, so this relay goes off, okay? So it turns the relays back to its, remember it was closed, so it'll open it, it'll close it, okay, it goes off, and everything goes back to normal. And if you notice, nothing goes through. Nothing goes through here, nothing goes through here, nothing goes through here. So the whichever of the LEDs was on, it goes off, and you're ready to start again. So you have to cut the power to the, I mean, remember the latching, self-latching. Well, when you cut the power, you cut the latching, so everything goes to normal, and that's how it is. Okay, so we'll use this for the Patreon page and put it up, and you guys can download this and play with it. Okay, here I'm installing the toggle switches that are going to turn on the red LED lights on the front, and here I'm making a fast schematic. First we have the switch, then I'm using a 330 ohm resistor, then there's the sign for the LED, and then it goes back to ground. It's as simple as that. I'll put the schematic on the Patreon page if you guys want to download it and do it. To the schematic, I'm going to add the other two LEDs. So it'll be 3 switches, 3 LEDs. You're going to use 3 resistors. And this video, as you can see, I'm just soldering the resistors to the LED, to the cable. And see, you can see all the 3 go to the same ground. So that's what I'm doing right there. I'm soldering the ends of all the grounds. That's 3 grounds coming from the LEDs, and another cable is going to go to the ground on the battery. And then soldering the cables that go to the switch and then to the LED. Then I'm putting the toggle switches on the box, putting the nuts on them. I use some oh, actually that toggle switch broke, so I had to like use another one. You have to be careful with the heat on those toggle switches. The casing is plastic and they melt really fast, so you just have to be really careful. But then I use some hot glue gun, as you can see there, to protect the connections, so you know any movement is going to start wearing them out. So I put the lid on the bottom already, everything's set. And as you can see, it's finished. You hit the toggle switch, 1 LED comes on, 2, so it's kind of like the 3 strikes you use on Family Feud. So like somebody gets something wrong, you know, you toggle switch. The game, it's working. There's a reset button. Somebody clicks it, it's ready to go. Somebody gets the wrong answer, you start hitting the lights on the back, and that's a Family Feud game switch box. So I hope you guys enjoy this, and thanks to my Patreons, Jason C, Siri, and Steve Jones, for supporting me this couple past months. Thank you for supporting me, and I haven't had a video, but I'm back on it. Thank you very much. Extra footage and STL files are available in my Patreon page. Don't forget to like, comment, and subscribe. Here you can also click on the links for the videos on how I printed, painted, and made the electronics for my Iron Man helmet. I'll see you next video.